Hello, I'm Hank Green, and welcome to this special edition of SciShow News. 8 months ago, the final stage of the Mars Science Laboratory's launch vehicle pushed the craft to 13,000 miles per hour, ready for its journey to Mars. The Mars Science Laboratory, or Curiosity rover, is a massive interplanetary payload, the largest ever delivered to the surface of a planet, and 5 times larger than any previous rover. The logistics of getting it not just to the surface of Mars, but to a very particular spot on the surface of Mars, boggle my mind. The calm of the first 8.5 months of this journey will end as the spacecraft enters the Martian atmosphere, still traveling at around 13,000 miles per hour. At that moment, the craft will lose contact with us. 7 minutes later, it will be going 0 miles per hour, either sitting peacefully on the surface of the planet, ready to begin its mission, or scattered across the landscape with no sign as to what went wrong. NASA scientists and engineers call this the 7 minutes of terror. As the craft enters the upper atmosphere and jets align it to the perfect entry vector, the friction of the atmosphere heats the heat shield up to 1600 degrees Celsius while slowing the craft down to a much more manageable 1,000 miles per hour. Still, though, faster than the speed of sound. But while the Martian atmosphere is certainly thick enough to burn up an improperly shielded spacecraft, it is not thick enough to slow it down at subsonic speeds. So that job is done by a parachute. The largest supersonic parachute ever designed, in fact, weighing only 100 pounds and yet capable of withstanding 6,500 pounds of force. But now, I have for you some more scary news, because the Martian atmosphere is so thin, the parachute isn't enough to achieve a safe landing speed, so, you guessed it, a third stage is necessary: the powered descent. The parachute detaches and the fallen craft is caught by retro-rockets which slow it further, jetting it away from the parachute so it doesn't get tangled up, and eliminating not just vertical but horizontal speed. The craft now uses radar and cameras not just to see how high it is, but to spot its landing area, so that it can hit the surface in a previously defined area that isn't just safe, it's also scientifically fascinating, at the base of a 6-kilometer high mountain. However, there remains one final problem. If it lowered itself all the way to the surface on rockets, the amount of dust kicked up in that process could permanently damage many of the instruments. So instead, the lander is lowered down on a 21-foot tether, a system engineers call the sky crane maneuver. After the wheels hit the ground, the rocket portion detaches, accelerates up, and then crashes at a safe distance. At this point, and only if all of those things go perfectly, the craft will send out a signal letting us know that it is safely on the planet's surface, and we can all let out a huge sigh of relief. I will be watching and live tweeting the night of August 5th, 1:30 a.m. Eastern, 10:30 p.m. Pacific. Please join me for one of the most intense scientific moments in human history. Thank you for watching SciShow News.